Okay folks, so this is question 5 in your Reacting Mass Calculations 1 task, and it says what mass of carbon dioxide is needed to react with 480 grams of iron oxide. So again, first things first, identify the question mark. What mass of carbon monoxide? So which of these species here is carbon monoxide? Hopefully you've identified it as that. And it's needed to react with 480 grams of iron oxide. So 480 grams of iron oxide. So it's the thing with iron and oxygen in it. And you've completed the first step. And then I'm just going to set up my grid lines again, like I've done with all the other questions so far. So I'm starting here. I'm going to go there, there, and up there. And the third step, like you say, you go mass into moles, check the ratio, moles into mass. So I'm going to divide by MR here. Check the ratio. So the ratio here, look, is 1 to 3, using the big numbers. And then I'm going to times by the MR there. And then before I actually start, I'm just going to calculate the MRs, because in exams you do get some marks for doing this step. So I'm going to make sure I can do that first. So I've got Fe2O3, which is 2 Fe's and 3 O's, and using the mass numbers at the top of your page, hopefully you will get that to be 160. And over here the MR is CO, so the molecular formula is CO, so it's 1 carbon, 1 oxygen, so that's 12 plus 16, which is 28. Notice, you do not use the big numbers to calculate MR. And I think I've pretty much got everything in place to have a go at this calculation. So let's try it then. So the first step, 480 divided by 160 equals 3. So I've got 3 moles of iron oxide. It's a 1 to 3 ratio, so this number on this side must be 3 times as big as this number. So that should be 9 moles of carbon monoxide needed. And then finally go 9 times the MR, which is 28, will give me an answer of 252 grams. Okay, so why don't you have a go now at question 6. Pause the video and I'll go through the answer in a couple of minutes. Okay. Right guys, question 6 is on the board now, so let's again work through it as we've done so far. Step 1, identify your question mark. So what mass of carbon dioxide? So carbon dioxide is the thing I'm trying to figure out. So which of these things, H2O, CO2, O2, C4H, which of those is carbon dioxide? Hopefully by now in your education, you know that CO2 is carbon dioxide. And we're starting with 5.6 grams of butene. You'll know by the end of the year 11 course what that is, but in this particular question, it does tell you what the formula is. So it's C4H8. So I've got 5.6 grams of that. And again, I'm going to set up my pathway. There to there, there to there, and up there to there. Okay, so again, same step. I'm going to divide by the MR here. I'm going to times by the MR here. And this middle step is the ratio. So what is the ratio of this chemical to carbon dioxide on this side? So it's a 1 to 4. So whatever number we get here, we'll need to multiply by 4 to end up with the correct number of moles over there. And again, before I start, I'm just going to calculate these MRs to make sure, because then I can get, I'm going to calculate the MRs before doing any calculations. If I calculate an incorrect MR, I will get error carried forward. So if I don't get the correct number here, but I follow through the pathway perfectly, I can still get to most of the marks for the question. So the MR of C4H8, it's 4 C's and 8 H's using the masses at the top of your page. So that's 4 times 12, which is 48, plus 8, which is 56. And the MR of CO2 over here is 1 carbon, 2 oxygens, so the MR is 44. So hopefully I've got everything in place now to actually have a go at the calculation. So I will get my calculator and I'll give it a go. So 5.65 by 56, fairly straightforward maths this one, that's 0.1 moles. So 5.6 grams of C4H8 is 0.1 moles. Don't forget, a mole is just a number. It's a very, very big number, and this is just 0.1 or a tenth of that. So it's 1 to 4, so this number over here should be 4 times as big. So I've got 0.4 moles over there, and then just times it by the MR, which is 44, which is 17.6 grams. Okay. I'm going to wipe the board in a moment. Have a go at question 7 now. This will be the last one I do on this video, and then hopefully you'll be able to get on with the rest of it in good time. Okay. Okay folks, so this is the last one I'm going to do on this video. It's question 7, and again I'm just going to follow exactly the same procedure I've done so far with the previous 6 questions. So identify the question mark. What mass of oxygen is needed? So which of my chemicals here is pure oxygen? So it's only got O's in it. It must be that just there. To react with 8.5 grams of hydrogen sulfide. So there's no formula there, so I'm going to have to work out what hydrogen sulfide is. Hopefully by the name you can see that it's got hydrogen and sulfur in it. So it must be that one there. So it's 8.5 grams of that. And again, I'm going to set up my grid. Perfect, shorten that arrow a bit. I know that I'm going to divide by MR there, times by MR there, and then look at the ratio here. So the ratio is 2 to 3. So it's an awkward ratio, but it's nothing we can't handle. And I'll show you how now. Okay, so again, before I start, I'm going to work out the MRs of H2S and O2. So using your the mass numbers at the top of your page, sulfur weighs 32. Each of the hydrogen weighs 1, so that should give you an MR of 34. And over here, the MR of oxygen, it's just 2 oxygen atoms, not 1. So 1 oxygen weighs 16, so 2 will weigh, or have a mass, sorry, of 32. And now I've got everything sorted to have a go at this calculation. So I'll get my calculator. 8.5 divided by 34 is 0.25 moles. Now here's the tricky bit. The ratio is 2 to 3. Okay, so what do I need to do with a 2 to 3 ratio? Well, the easiest way to do it, I'll find, is if you divide by 2 and then times by 3. So I've got 0.25 on my calculator, divide by 2, times by 3, I end up with 0.375. And that trick will work for any ratio. So even a 1 to 4, all right, you can divide by 1 times by 4, for example. And then the final step, times by the MR, which is 32, and it gives me 12 grams of oxygen needed. Now, hopefully, as you go through this, all right, you're getting more and more confident with it. And like I say, the mark scheme is attached to the assignment. So please do make sure you check it as you go through. But any issues, like I said, after I've gone through 6 or 7 now with you, right, if there are any issues, please, please, please do send me an email, all right, and I'll gladly help out the best I can. Okay, enjoy.